All right, I'm going to try something a little different so we can see the calculator here. But here we go. This is the fish FRQ. Okay, so it tells us that the fish in our lake at a rate modeled by a function E given by this right here. So that's a rate function. Pay attention to that, people. And then it says fish leave at a rate modeled by this function. So we're given two rate functions. Both E and L are measured in fish per hour. So there's another hint. They give us the unit measures. Whenever you see per hour or per second, whatever, that's usually a rate. It's describing a rate. Okay, so looking at A, it says how many fish enter the lake over the 5-hour period from midnight, which is t equals 0, to 5 a.m., which is t equals 5. Give your answer to the nearest whole number. So what I'm going to do here is set up an integral function, because E gives me the rate at which the fish enter. So if I want the amount of fish that enter, I must do the integral of that. Okay, a rate function is like f prime. What we want is f, and we want to plug 5 into f to find out the amount of fish that have entered the lake. So when we do the integral of E, we are going to find the amount, the integral of a rate function. So to do that, we're going to need our calculator. Okay, so here, let me clear all this right here. When I use my calculator and I'm given functions, I want to make sure that I am inputting the functions into my calculator very carefully. Okay, and that's what I did. E, I put in y1, so we got 20 plus 15 sine, and we have pi times t. In my calculator it says x divided by 6. And then I also checked my mode, which has my radians down here. I want to make sure that I'm in radians. Whenever you use a trig function, you want to make sure you're in radians. And then I'm going to go ahead and plug in also my the exiting rate, the leaving rate, I guess. 4 plus 2 raised to the 0.1 times x squared. Okay, so I put that in there, but I only need y sub 1 because that's my entering function. That's the capital E. And I go back to my home window and then press math. When I press math, you can see it right here on the left side. It's right underneath the second and the alpha button. I'm going to press nderiv. Now not nderiv. I'm going to press FNINT, which is the integral. Now my calculator has what you would call math print for a Texas Instrument. If you don't have math print, you will see FNINT parenthesis. And what you do with that, I believe, you're going to have to look this up to guarantee it. I believe you put the function in, then you put the variable that you're integrating with, and then you put the integrals, like 0, 5. So you go rule, x, 0, 5. But if you have math print like I do, you can just put all the values in where they're supposed to go. Now for my Integrand, I can use the vars button because I put my function in there. That way I don't have to keep retyping my function. Instead of doing y sub 1, you could actually type out the function that they give us in the directions. But what I'm doing right now is way easier, way more efficient, because since this is a calculator problem, we're going to be using the calculator throughout the whole time. So I only want to make sure I type it in once correctly, then I could just use y sub 1 for the rest of the problem. So I put y sub 1 and I put my x for my variable of integration, and then I press enter, and it gives me 153.457, which actually rounds up to 58. But when I look at the directions, it tells me to round to the nearest whole numbers. So I'm going to say it's about 153 fish. It doesn't ask for a label. I don't even think I get a point for it, but it is correct. All right, so let's look at the next one. We're going to look at B. Now for B, it says, what is the average number of fish that leave the lake per hour over the 5-hour period? Okay, now when you guys hear average, the most common average is the mean. And to find the mean, what you do is you add a bunch of numbers together, and then you divide by the number of numbers that you are adding. For calculus, you're going to actually divide by the interval that where you are adding all the values up. So I'm going to start off with multiplying by 1 over 5 minus 0. Now the 5 is the upper bound and the 0 is the lower bound. okay, for my integral. And my integral looks like this. Now, an integral is actually a sum of all the values. That's why the integral sign looks like an elongated S. And since we're doing the amount of fish that are leaving the lake, I have to use the L function. Okay, so this is essentially going to divide my sum. See, that's what I think of when I think of average. I go my sum divided by the number of numbers that I'm adding up. In this case, it's the interval. So let's plug that into a calculator. Now, I already plugged in my leaving function into y sub 2. So now I'm going to say 1 divided by 5, because that's what 5 minus 0 is. And I'm going to multiply that times FNINT from 0 to 5 of y sub 2. And my variable of integration is x. I press enter. I get my answer. It doesn't say where to round it. So if it doesn't say where to round it, what you do is you round to the nearest third decimal place. In this case, it's 9. So it's 6.059 fish. This is our average that are leaving from 0 to 5. All right, next, let's look at letter C. Letter C says, at what time t for this interval from 0 to 8 is the greatest number of fish in the lake? So that's a max, people, an absolute max. And it says justify your answer. So the way I like to do absolute maxes, if you guys look at the scoring guide afterwards, they had 2 ways. I understand the other way, but I like my way better. What you do is you test the endpoints and you have to test critical values. But in order to test things, we're going to need the function that we're going to test. So we need a function that gives us the number of fish at a certain time. And so that function is going to look like this. I'm going to name the function A for amount. And then I'm going to say I'm going to subtract E and L, because this is entering and this is leaving. Okay, so if I do the integral of E, it'll give me the total number of fish that entered the lake. And if I do the integral of L, it'll give me the total number of fish exiting the lake. And so notice that I use T here. So I had to use X right here and here and here. Because these variables in here shouldn't be the same as this. So I wrote a function of t that would give me the total amount of fish at any given time. So like if you plug the number right here and then you plug the number right there, then you do the integral of the rate functions right here, it'll give you the total amount of fish at that moment. All right, so enough talking about my function. Next, let's get back to finding an absolute max. I'm going to have to test the end points, which is 0 and 8. Now, I'm also going to have to test the critical value. Now, in order to find the critical value, I'm going to have to find A prime. So going to this, I'm going to have to use the fundamental theorem of calculus part 2. And the fundamental theorem of calculus part 2 just essentially has us take this guy and plugs them into those. Because if we actually did do the antiderivative of each of these and then plug in t and 0, and then take the derivative of that, this is what we would get. We would get E of t minus L of t. So A prime is that. So I'm trying to find out where this equals 0. Now, it sounds complicated, but luckily we have our handy-dandy calculator. So what I did is I went back to the y equals window. I unhighlighted my y1 and y2 so that my function didn't graph that. And then in y sub 3, I put in y1 minus y2. That is E minus L. All right. And the reason why I did that, because now I can just do a graph and I can, whoops, I forgot to highlight it. I gotta highlight it. Now on your calculators, you would just want you'd want the equal sign highlighted, and you just use the arrows to go over to the equal sign, and then once you're highlighting the equal sign, press enter, and that way you can make sure that that one is being graphed. So if I hit graph, I can see it. So pretty much what I just did is I created a sine line graph at 6.203.5. I have an x-intercept. Before the x, I have positive. After the x, I have negative. And so if I did create a sine line graph, it would go positive, negative, because we're above the x-axis, then below the x-axis. And so I know that my x-intercept is at 6.204. I would round the 3 up because of the 5. Now, if you wanted to find a 0 on your graphing calculator, what you're going to do is, see, mine doesn't have it, but you would press second, and then you would see right above where it says table, my table button, I don't know if that's your table button, but it's the same button on your calculator. It'll say calc. So you're going to press second and calc while you're on the graph. You press second and calc, then you're going to select the 0 button. Then you got to pick a lower boundary, enter, upper boundary, enter, and then you got to put your cursor next to where you want to find the x-intercept. Then you press enter, and it'll find it for you, and that's what we need. So we got our x-intercept, our critical value. So I'm going to test the 0, the 8, and the 6.204. To test those, I'm going to need my function that I made up, the a function. So I'm going to say, let's go math, FNINT. I'm going to go from 0 to 0, which I know is going to be 0, but I'm going to put it in anyways, just so you guys can see it. I'm going to go y sub 1 minus y sub 2, and put the integral of the variable integral right there. I get 0. Now I'll do it again on my calculator. I'm able to go up and highlight what I want to do and press enter, and I'm going to take the upper bound and change it to 8 to find that value. Now I'm going to do it again, and I'm going to change the 8 to 6.204. Press enter, and I see all my values. Okay, I get all my values from that. So I know the amount of fish at each of these points. Clearly, at 6.204, we have our max. So I'm going to state at t equals 6.204, the number of fish is at a max. All right, C is done. Let's look at D now. It says, is the rate of change in the number of fish in the lake increasing or decreasing? So this question is actually asking, when is A prime, is A prime increasing or decreasing at 5, at t equals 5? Now, if we want to know if A prime is increasing or decreasing, we're going to have to find A double prime. So let's find A double prime. To find A double prime, I'm going to go back and look at A prime, take the derivative of that. That would simply be E prime of t minus L prime of t. And then I'm going to plug 5 into that to see if I get a positive or a negative answer. Now, to do that on my calculator, what I would do is I would first, actually, I can just do it both at the same time. So I'm going to say math, n deriv, we're going to say n derivative of x, and I'm going to put y1 right there, minus y2, and then I'm going to say at 5. Because your calculator can take the derivative at any value that you decide. And when I do that, I get negative 10.72, and then it would be a 3. So the important thing to note here is that we're less than 0. And I think you got to state that. Okay, now because A double prime is less than 0, the rate of change is decreasing at 5. And I should probably write that too. At t equals 5. All right, and that's the end of that. If you guys are curious, you guys can look at the scoring guide right here. See if that's helpful for you. Email me if you guys